Hello student, welcome back. Today we will going to discuss the important topic, that is current conduction in a metallic wire or a metallic conductor and the relation between electric field and drift velocity. So before start with this, first we will discuss, this is a copper wire and in this the zigzag motion of a free electron, because with the help of an electric field is moving in this direction. This is the n number of an electron, or we can say a free electron. In this, the two important term, relaxation time, and it is denoted by tau. This is tau. Relaxation time, it is tau. Second is drift velocity. It is represented by V suffix D. So first we will discuss what is relaxation time. Relaxation time means if two free electrons, the average time in which they collide. What is the average time in which, if suppose here the electron number 1, or here we consider suppose the electron 2. So if the average time with which two electrons can coincide or collide with one another, then the average time is called as relaxation time. It is denoted by T, and the average velocity with which two electrons get drifted, means shifted from one place to another with the influence of an electric field, then it is called as drift velocity. The approximate value of drift velocity is 10 to the power minus 5 meter per second, and the approximate time or the average time in which the two electrons get drifted, or the average time, is 10 to the power minus 14 second. Clear? This is the theoretical part. Here in this we also find the relation between electric field and drift velocity. So we considered over there is the copper wire. The length of a wire is small l. The drift velocity Vd is moving in this direction. Electric field moving in this direction, and there is the potential drop Vd. So we know very well electric field is E equals to potential per unit length equals to V is potential and L is the length. So electric field equals to potential per unit length. Then F is the force, and with the quantization of charge we know very well minus E is an electron and E is the electric field intensity. The formula of force is minus E, capital E, and we know the another formula of force is mass into acceleration with the Newton's second law, mass into acceleration. With this formula we find the value of A is F upon m, force upon mass, and put this force value F by E over in this equation. So A equals to minus small e capital E by m. A is an acceleration, E is an electron, capital E is an electric field, and m is a mass of a body or any electron. So A equals to minus E small e capital E by m, and we know very well what is acceleration. Acceleration is velocity upon time. Acceleration equals to velocity upon time. So we write acceleration is A, velocity because we want to find the relation between drift velocity. So we have write V suffix D. Vd means drift velocity with respect to time. So Vd equals to A T, or in place of T we also write, if you want, tau, because it is also a relaxation time. So Vd equals to A tau. Now we put this acceleration value over there and we find the relation. So Vd equals to, what is the value of A? Minus of E minus small e capital E small e capital E. This T will replaced by tau, because it is also relaxation time, tau by m. This is the final result. Drift velocity equals to small e capital E tau by m. Minus sign indicates the direction which is opposite to the direction of a flow of a current. This is the final result, the relation between drift velocity and electric field. Clear? So Vd equals to minus E capital E tau by m. Also if you write Vd equals to small e capital E tau by m. This is the final result where we can talk about the relation between drift velocity or electric field, or you can say drift velocity and relaxation time. Clear? I hope you understand the concept. In the next video, we will discuss further the relation between J equals to sigma E. Thank you, students.